The National Electrical Code requires that electrical equipment be installed and maintained in accordance with its listing. Any modifications to Underwriters Laboratories listed device could void its certification and compromise its safety. High-pressure sodium light fixtures require specific ballasts and igniters to operate safely. Removing these components could create electrical hazards, such as fire or shock. Insurance underwriters consider factors such as compliance with codes and industry standards when assessing claims. If a fire were to occur in the area where the modified fixture is located, the underwriter would likely investigate the cause and determine if the modifications contributed to the incident. If it is found that the fixture was not Underwriters Laboratories listed or was modified in a way that compromised its safety, the underwriter could deny the claim. Screw-in fluorescent bulbs have different electrical characteristics than high-pressure sodium bulbs. Using an incorrect bulb in the fixture could damage the fixture or create other electrical hazards. The lumen output and color temperature of fluorescent bulbs may not be suitable for the intended application, compromising safety and visibility. Maintain the high-pressure sodium fixture and its components according to the manufacturer's instructions and industry standards. Use only Underwriters Laboratories listed replacement pots for any repairs or replacements. If a different lighting solution is desired, consider consulting with a qualified electrician to explore alternative options that meet code requirements and insurance underwriter expectations. Firstly, the National Electrical Code, or NEC, mandates that all electrical equipment be installed and maintained according to its listing. This means that if a device is certified by an organization like Underwriters Laboratories, or all, it must be installed and maintained in a manner consistent with that certification. Modifying a UL-listed device can void its certification, potentially leading to safety issues and code violations. High-pressure sodium, or HPS, light fixtures are specifically designed to operate with particular ballasts and igniters. These components are essential for the safe and efficient operation of the fixture. The ballast regulates the voltage and current supplied to the HPS lamp, while the igniter provides the high-voltage pulse needed to start the lamp. Removing these components and replacing the HPS lamp with a screw-in fluorescent bulb can create several electrical hazards. For example, the fluorescent bulb may not be compatible with the existing voltage and current levels, which could lead to overheating, electrical shorts, or even a fire. There is also a risk of electric shock if the fixture is not properly grounded or if the wiring is damaged during the modification process. Secondly, insurance underwriters play a critical role in assessing and managing risk. When evaluating claims, they consider various factors, including compliance with codes and industry standards. If a fire occurs in an area where a modified HPS fixture is located, the insurance underwriter will likely investigate the cause of the fire. They will want to determine if the modifications to the fixture contributed to the incident. If the underwriter finds that the fixture was not UL listed or was modified in a way that compromised its safety, they may deny the claim. This is because the modifications would be considered a deviation from accepted safety standards, increasing the risk of a fire. Moreover, insurance policies often include clauses that exclude coverage for losses resulting from non-compliant electrical work. Therefore, it is crucial to ensure that all electrical installations and modifications are performed by qualified professionals and in accordance with applicable codes and standards. Thirdly, screw-in fluorescent bulbs have different electrical characteristics compared to HPS bulbs. HPS bulbs typically require high voltage and current to operate, while fluorescent bulbs operate at low voltage and current levels. Using a fluorescent bulb in an HPS fixture without the proper modifications can damage the fixture and create electrical hazards. The ballast in an HPS fixture is designed to provide the specific voltage and current required by the HPS lamp. If a fluorescent bulb is used with the HPS ballast, it may not receive the correct voltage and current, which can lead to overheating and premature failure of the bulb. Additionally, the fluorescent bulb may not be compatible with the fixture's wiring, which can create a risk of electrical shorts or fire. The lumen output and color temperature of fluorescent bulbs may also not be suitable for the intended application. HPS bulbs typically produce a warm, yellowish light that is well suited for outdoor lighting applications. Fluorescent bulbs, on the other hand, can produce a variety of light colors, ranging from cool white to warm white. If a fluorescent bulb with an unsuitable color temperature is used in an outdoor lighting application, it can compromise safety and visibility. For example, a cool white fluorescent bulb may not provide adequate illumination in foggy or rainy conditions, making it difficult for drivers and pedestrians to see. Fourthly, to maintain the safety and reliability of HPS fixtures, it is essential to adhere to best practices for maintenance and repair. This includes following the manufacturer's instructions for maintenance and using only UL-listed replacement parts for any repairs or replacements. The manufacturer's instructions provide detailed information on how to properly maintain the fixture, including cleaning, lubrication, and inspection procedures. Following these instructions can help to prevent problems and extend the life of the fixture. When replacing parts, it is crucial to use only UL-listed replacement parts. UL listing indicates that the part has been tested and certified to meet safety standards. Using non-UL listed parts can compromise the safety of the fixture and create a risk of electrical hazards. If a different lighting solution is desired, it is recommended to consult with a qualified electrician to explore alternative options that meet code requirements and insurance underwriter expectations. A qualified electrician can assess the existing lighting system and recommend a replacement system that is safe, efficient, and compliant with all applicable codes and standards. They can also ensure that the new system is properly installed and grounded, minimizing the risk of electrical hazard. In summary, modifying HPS fixtures by removing the igniter and transformer and replacing the HPS lamp with a screw-in fluorescent bulb is not recommended. This type of modification can compromise safety, void UL listing, and potentially result in a denied insurance claim in the event of a fire. It is essential to maintain HPS fixtures according to the manufacturer's instructions and to use only UL-listed replacement parts for any repairs or replacements. If a different lighting solution is desired, it is recommended to consult with a qualified electrician to explore alternative options that meet code requirements and insurance underwriter expectations. Moreover, consider the following points. Firstly, the National Electrical Code, specifically Article 410.130, addresses the modification of luminaires. This section emphasizes the importance of maintaining the luminaire's original listing and labeling. Any modification that deviates from the manufacturer's specifications can void the listing and create potential safety hazards. Secondly, the underwriters' laboratories, or all standards for luminaires, such as UL 1598, provide detailed requirements for the construction, performance, and safety of lighting fixtures. Modifying a UL-listed luminaire can compromise its compliance with these standards, potentially leading to electrical shock, fire, or other hazards. Thirdly, the light output and energy efficiency of fluorescent bulbs may not be comparable to those of HPS bulbs. HPS lamps typically provide a higher lumen output per watt compared to fluorescent lamps, making them more suitable for outdoor lighting applications where high levels of illumination are required. Fourthly, the color rendering index, or CRI, of fluorescent bulbs may not be as high as that of HPS bulbs. CRI is a measure of how accurately a light source renders the colors of objects compared to natural sunlight. HPS lamps typically have a lower CRI compared to fluorescent lamps, which can affect the appearance of colors in the illuminated area. Fifthly, the operating temperature range of fluorescent bulbs may not be as wide as that of HPS bulbs. HPS lamps can operate reliably in a wide range of ambient temperatures, making them suitable for outdoor lighting applications in various climates. Fluorescent bulbs, on the other hand, may be more sensitive to temperature variations, which can affect their performance and lifespan. Sixthly, the ballast in an HPS fixture is specifically designed to provide the high voltage and current required by the HPS lamp. Replacing the HPS lamp with a fluorescent bulb can overload the ballast, leading to overheating and potential failure. Additionally, the ballast may not be compatible with the electrical characteristics of the fluorescent bulb, which can result in poor performance and reduced lifespan. Seventhly, the igniter in an HPS fixture is responsible for providing the high voltage pulse needed to start the HPS lamp. Removing the igniter and replacing the HPS lamp with a fluorescent bulb can create a safety hazard, as the igniter may still be energized even when the fixture is not in use. This can pose a risk of electric shock if someone comes into contact with the igniter. Eighthly, the wiring in an HPS fixture is typically designed to handle the high voltage and current required by the HPS lamp. Replacing the HPS lamp with a fluorescent bulb can create a risk of overheating and fire if the wiring is not properly sized and insulated. It is important to ensure that the wiring is compatible with the electrical characteristics of the fluorescent bulb and that all connections are properly made and insulated. Ninthly, the physical dimensions of fluorescent bulbs may not be the same as those of HPS lamps. Replacing the HPS lamp with a fluorescent bulb may require modifications to the fixture to accommodate the different bulb size. This can compromise the structural integrity of the fixture and create a risk of the bulb falling out or breaking. Tenthly, the disposal of HPS lamps and fluorescent bulbs is subject to different regulations. HPS lamps typically contain mercury, which is a hazardous material that requires special handling and disposal. Fluorescent bulbs also contain mercury, but in smaller amounts. It is important to dispose of both types of lamps properly to prevent environmental contamination. And additionally, consider the following key aspects of this situation. Firstly, referring to National Electrical Code Section 410.130 subsection G, it covers the modification of luminaires. It explicitly states that any modification to a luminaire must not alter its original listing unless the modification is performed by a qualified testing laboratory. Removing the HPS igniter and transformer and replacing the HPS lamp with a fluorescent bulb would undoubtedly violate this code. Secondly, insurance underwriters rely heavily on compliance with recognized safety standards and codes. If a fire were to occur due to a modified luminaire, the insurance company would likely investigate the cause and assess whether the modifications contributed to the incident. If the modifications violated NEC or UL standards, the insurance company could deny the claim, citing negligence or non-compliance. Thirdly, HPS lamps and fluorescent bulbs have different operating characteristics. HPS lamps require a ballast to regulate the current and voltage, as well as an igniter to start the arc. Fluorescent bulbs, on the other hand, use a different type of ballast and do not require an igniter. The existing ballast and igniter in the HPS fixture are not compatible with a fluorescent bulb, which could lead to electrical hazards. Fourthly, the lumen output, color temperature, and light distribution of fluorescent bulbs may not be suitable for the intended application. HPS lamps typically produce a warm, yellowish light that is well suited for outdoor lighting. Fluorescent bulbs can produce a variety of light colors, but they may not provide the same level of illumination or color rendering as HPS lamps. Fifthly, consulting with a qualified electrician is essential to ensure that any lighting modifications are safe, code compliant, and suitable for the intended application. An electrician can assess the existing lighting system, evaluate the alternatives, and recommend a solution that meets all applicable requirements. The electrician can also perform the modifications safely and professionally, ensuring that the luminaire remains compliant with safety standards. Sixthly, it is important to maintain the HPS fixture and its components according to the manufacturer's instructions. This includes regular inspections, cleaning, and replacement of worn or damaged parts. Properly maintaining the fixture can help to prevent electrical hazards and extend its lifespan. Seventhly, when replacing parts, it is crucial to use only underwriters' laboratories listed replacement parts that are specifically designed for the HPS fixture. Using non-UL listed parts can compromise the safety of the fixture and potentially lead to electrical hazards. Eighthly, explore alternative lighting options that meet code requirements and insurance underwriter expectations. There are many energy-efficient lighting technologies available, such as light-emitting diodes, that can provide comparable or better performance than HPS lamps while also reducing energy consumption and maintenance costs. A qualified electrician can help to evaluate these options and recommend the best solution for the specific application. Ninthly, consider the environmental impact of lighting systems. HPS lamps contain mercury, which is a hazardous material that requires special handling and disposal. Fluorescent bulbs also contain mercury, but in smaller amounts. Light-emitting diode lamps do not contain mercury and are generally considered to be more environmentally friendly. Tenthly, before making any lighting modifications, it is advisable to obtain written approval from the insurance underwriter. This can help to avoid any potential disputes or coverage issues in the event of a fire or other incident. The insurance underwriter may have specific requirements or recommendations for lighting modifications, which should be followed carefully. Lastly, always prioritize safety and compliance with applicable codes and standards. Modifying electrical equipment without proper knowledge and expertise can be dangerous and potentially lead to serious consequences. It is essential to consult with qualified professionals and follow their recommendations to ensure that all lighting modifications are safe and code compliant.